Debugging segmentation faults in C is one of the nastiest things to have to debug, particularly when the segmentation fault doesn't happen all of the time. So in this video, I want to give you a strategy for how to debug those kinds of problems, particularly when that segmentation fault is happening on a return from a function. So I have my main function here. It gets an int from a user, and we can just trust me that that works. And yes, A to I is a little risky. I'm not going to do any error checking on that. That's really not the point of the video. So we get the integer from the user, and then it calls this function up here. It does some stuff to a local array that will be in the stack frame, and then it returns, and whatever it returns, we print out. And if I run that and I give it a 3, that works beautifully. I run it and I give it an 8. That works beautifully. I run it and I give it a 20. That works beautifully. I run it and I give it a 12. Segmentation fault. Okay, so little numbers are okay, and 20 is okay, but 12 is not. Let's see, is 13 any better? No. Is 14 any better? No. Is 15 any better? No. Is 16 any better? Yes. Okay, so our first clue is there are 4 possible values that mess things up: 12, 13, 14, 15. So for now, I'm just going to play with 12 because I know that it breaks. And when we look at what happens, we'll try to explain why there are 4 values that fail. So let's run it again just to make sure. If I give it a 12, yes, segmentation fault. Okay, so the first thing is now I have a reproducible way to cause this problem. I know that 12 always causes it. So now that I can reproduce it reliably, now it's much easier to debug. It's not a sporadic thing. When I have a segmentation fault, the first thing I do is just run it in the debugger, because if I run it in the debugger will stop right at the moment that that segmentation fault occurs, and so I'll know where I am in my code at that point. So I run it in the debugger, I enter the 12, and this is where this line is where the segmentation fault happens. So because that is a call on a function, either it is failing going into the function or it's failing coming out of the function. There's nothing else going on in this line of code. So those are the 2 things that I have to worry about. So the first thing I'm going to do is I'm going to put a breakpoint at the beginning of the function. And if I get into it, then I know the call is okay. It's the return that is failing. So if I rerun this and I put the 12 in, I got to the, you can see in my call stack here, I am up in this index too far. So the call on index too far worked fine. And you can see in the main, we had called it from that line that we're afraid of now, because that's where the seg fault would happen. Okay, so that tells me that it is the return of index too far that is the problem. So what I want to do, because it's the return, I'm worried about the data in the stack frame that helps you make that return. So if I go to GDB and I dump the registers, if I spell better, we can see the stack pointer ends in E5D0 and the base pointer ends in E620. So if I dump the memory from the stack pointer, this top stack frame, the stack frame for this index too far, starts there and goes down to here. So if I was going to like take a screenshot, that is the current stack frame. If we look at the current stack frame, we can see always down here where the base pointer is pointing, you can see the old base pointer. So when the return happens, the stack pointer is going to move down to here, and the base pointer is going to move to this address. And then we can see here, this is actually address into the code segment. That's the return control word that is the instruction that we should return to. So when a return happens, that data right there is really important for how we do a return. So I'm going to save that screenshot and put a breakpoint at the end of the function because everything looks okay right now. I want to see what does it look like at the end of the function. And I'm going to tell it to resume the program. And we can see, remember the stack frame is here to here. Can I highlight that? Oh, I can. There's the stack frame. There's been some stuff that has been written in the middle of the stack frame. That's actually my array. You can see this loop is putting the numbers 1 through 10 into this array. So we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the array, and that's why all of that has been marked as changed. But when we compare it to our old, what did it look like at the beginning of the call? Look at this. Oh, that's nasty. You marked right over it. Look at this line because that's the one that has the information to make the return. If I look over here at this line, which is the same address, this E620, the part of the old base pointer has been overwritten with a 2A. The rest of this line looks just fine. But this 2A is the problem. So when the return executes, the machine's going to try to put this address, this old base pointer address, into the base pointer, and the machine's going to say that's not a legal pointer, segmentation fault. So our clue, so now we know exactly where it is getting corrupted, and we know exactly what value is being put into it. That 2A is 42. So I can look back at my code and see a 42 getting written. Now, I will admit it's not always as obvious as there's a 42 right there, but I know what behavior I'm looking for. I'm looking for something that is writing a particular value. So that statement is overwriting the old BP, and that's causing my seg fault. And the reason that that statement is doing it, remember I had entered a 12. So G has a 12 in it. My array only is 10 things long. So my array is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the part that I allocated for the array. 10, 11, 12. So the fact that I entered a 12 made line 36 store a 42 on top of the old BP. That is why the return is getting the seg fault. Now, if you remember, we said that the seg fault happened for 12, 13, 14, 15. 12, 13, 14, 15 is that's index it by 12, that's index it by 13, that's index it by 14, and that's index it by 15. So with those particular 4 values, the 42 gets written in a place that screws up our ability to do a return. When I index it by 20, because remember I entered a 20 and that was fine, it wrote the 42 somewhere down here. So this was 12, 13, 14, 15, 16, 17, 18, 19, 20. It wrote it here. That corrupted something, but it didn't corrupt exactly the things that the return needed. So the return was still happy. So the reason 12, 13, 14, 15 happened is because they stepped on the part of the stack that holds the data that the return has to do and made what used to be a valid pointer into an invalid pointer. So our steps to debugging a seg fault on a return are run it in the debugger to see exactly what line the seg fault is happening on. If that line is a call on a function, then the seg fault is either happening on the way into the function or on the way out of the function. So put a breakpoint at the top of the function and see if you get into it okay. In this case, we did get into it okay. So then take a picture of the stack frame, because now we know that the seg fault is happening on the return. And we need to figure out what part of the stack frame got corrupted to make the return not happen. So take a picture of the stack frame right at the beginning of the function. That tells you what it looks like when it's good. Put a breakpoint on the return. Look at the stack, the call stack, the stack frame again, and look at what's different in that line that holds the old BP and the return control word. Now, I'm doing this on a Windows machine, so the stack looks a particular way. The same strategy works no matter what machine you're working on, but you need to know on your machine where do the old BP and the return control word get stored, because those are the things that can cause a seg fault on a return. I hope that was fun. Thanks.